Morning students, welcome to class 11 chemistry. We will have numerical session today. So go through this numerical. So you can see here 5-liter vessel contains 1.4 grams of nitrogen. When heated to 1800 Kelvin, 30% of molecules are dissociated into atoms. Actually nitrogen is a molecule. When it is heated to 1800 Kelvin temperature, nitrogen atom dissociates into individual nitrogen. So N2 molecule dissociates into individual nitrogen atoms. Calculate the pressure of the gas at 1800 Kelvin temperature. So actually initial number of moles of nitrogen. Initially reactants. So there is a reversibility symbol here between nitrogen and nitrogen atoms, nitrogen molecule and nitrogen atoms. Now here initial number of moles means here number of moles of nitrogen, how much? Mass by gram molecular mass. What is the gram molecular mass of nitrogen? 28. So here if you calculate initial number of moles, you will get 0.05. So initial number of moles 0.05. Initially products concentration will be 0. Only reactants, before going to start the reaction, only reactants will be present. So products will be 0. So after some time, so after dissociation, so number of moles after dissociation. So number of moles after dissociation, what happens? Initially 0.05 moles are there. So here 0.05 minus. So how much extent it underwent dissociation? 30%, means 30 by 100 into out of into 0.05 you have to take. That is number of moles after dissociation. And here it will be 2 into 0, 2 moles of nitrogen is there, no? That's why 2 into 0.05 you have to take. Okay. So now what we will do is, so if you calculate this number of moles after dissociation, if you calculate this one, so here you will get 0.05 minus 0.015, and here how much you will have? 0.035, and here number of moles after here this 0.030. Okay. Now what we will do now? Total number of moles you have to calculate. Total number of moles is equal to you have to take 0.035 plus 0.030. So how much you will get? 0.065. That is the total number of moles. So total number of moles you can take it as N. Okay. After this, volume is given as 5 liters. Temperature is given as 1800 Kelvin. Pressure we don't know, X. So you apply the equation PV is equal to nRT. So from this P value is asking, so nRT by V. So N value how much? 0.065 into R value you have to take 0.0821 into temperature 1800 divided by volume in liters, how much? 5. So solve this one, you will get answer in atmospheres. Next some students. On a certain humid day, the mole fraction of water vapor in air at 25 degrees Celsius is given 0.0287. If the total pressure of air is 0.977 bar, calculate the partial pressure of water vapor in air. Calculate the partial pressure of water vapor in air and relative humidity if vapor pressure of water at 25 degrees is given. So here mole fraction of water vapor is given. First of all, note from that data you enter. So from that you can write mole fraction of water vapor. So mole fraction of water vapor, that is water vapor, that is given as 0.0287. So total pressure P total, how much it is given? 0.977 bar. That is the total pressure. So partial pressure of water vapor. So we are supposed to calculate partial pressure of water vapor is equal to, what is the formula? Mole fraction of water vapor into total pressure, P total. So you apply this one. So partial pressure of water vapor is equal to mole fraction how much? 0.02 leads on into 0.977 bar, that is equal to 0.028 bar. Next, after getting partial pressure of water vapor, percentage of relative humidity is asking. Percentage relative humidity is equal to partial pressure of water vapor in air divided by vapor pressure of water divided by vapor pressure of water into 100. So if you take this one, substitute the given data. So how much we got here? 0.028 by 0.313 into 100. And you solve this one, you will get percentage relative humidity. Next. See this one. A 4:1 molar mixture of helium and methane is contained in a vessel. Two gases, helium and methane. Due to hole in the vessel, the gas mixture leaks out. What is the composition of mixture effusing out initially? So this is based on Graham's law. Rate of diffusion of helium by rate of diffusion of methane is equal to square root of molecular mass of methane divided by molar mass of helium. So as it is, we got helium diffuses. So from this you can write rate of diffusion of helium is equal to 2 times rate of diffusion of methane. So molar ratio of helium is to methane. Molar ratio is asking. Molar ratio of helium is to methane he is asking. So from that you will get 8:1. Do it. Molar ratio he is asking. So molar ratio of MHE by MCHO you are supposed to calculate. Okay. Apply that, you will get. Put it on the paper, right? Next. Very, very important model. This is somewhat new concept. This is NCERT based actually. Very important model. All of you go through the question. Payload is defined. What is meant by payload? This is the term used in actually only in NCERT it is given this concept. Payload is defined as the difference. What is meant by payload? First of all, it is defined as the difference between mass of the displaced air and mass of the balloon. Mass of the displaced air and mass of the balloon. Calculate the payload when a balloon of radius 10 meters, mass 100 kg is filled with helium at 1.66 bar at 27 degrees Celsius. Density of air is given as 1.2 kg per meter cube. R value is given in terms of bar, dm cube, Kelvin inverse. So how to do this sum? Very important. First of all, what is given here? Radius of balloon is given. How much it is given? 10 molar. Radius of the balloon is given as 10 molar. Next, from that you calculate volume of the balloon. Volume of the balloon is equal to, what is the formula? It is a spherical in shape, na? So 4 by 3 pi r cube, 4 by 3 into 3.14 into r value 10 whole cube. So if you solve this one, you will get volume of the balloon as 4190.5 meter cube. 4190.5 meter cube. Solve it. So volume of balloon I got. Radius of balloon is given. So volume of helium filled at 1.66 bar. It is given. What data is given? Note down. Volume of helium filled at 1.66 bar and 27 degrees Celsius, and 27 degrees Celsius you have to take it as 4190.5 meter cube. Okay, so volume of helium filled at 1.66 bar pressure and 27 degrees Celsius, it is given as 4190.5 meter cube. So first of all we have to calculate calculation of mass of helium. We are supposed to calculate the calculation of mass of helium. So here what is the formula, students? PV is equal to nRT, that is equal to mass by gram molar mass into RT. So from this you can write W is equal to PMV by RT. So from this, what is the pressure? Molar mass given. You have to convert that molar mass into kg. What is the helium molar mass? How much? 4 grams, na? But I am taking in terms of kg. 4 into -3 kg per mole into, this is capital M value. And what is the pressure value given? 1.66 bar. And here it is given as 4190.5 into 10 cube dm cube. Be careful. Units you have to convert. Meter cube is different from dm cube. So convert them. Basing on R value I am doing. So here R value 0.083 bar into 300 Kelvin. So be careful. Not that much easy sum. You have to understand the unit conversions here. Finally, if you do that one, you will get mass in kg. So total mass of the balloon along with helium I am doing. Total mass of the balloon along with helium. Total mass of the balloon along with helium, that is equal to 100 plus 1117.5. So if you take this sum, you will get 1217.5 kg. So that is the total mass of the balloon along with helium. So next, maximum mass of the air. Maximum mass of the air that can be displaced by balloon to go up is equal to volume into density. So density is equal to mass by volume, na? From that mass I am taking. Mass is equal to volume into density. So maximum mass of air that can be displaced by balloon to go up, that is given, density is equal to mass by volume. So from that I got mass M is equal to V into D, right? So 4190.5 meter cube into 1.2 kg per meter cube. That is density of air given. This is the density of air you have to take. Next, after doing this multiplication, you will get 5028.6 kg. This is the maximum mass of air that can be displaced by balloon to go up. After that, payload. What is the formula for payload in the given question? Payload is defined as the difference between mass of the displaced air and mass of the balloon. So mass of the displaced air minus mass of the balloon. So here mass of the displaced air, how much, students? Mass of the displaced air 5028.6 kg minus mass of the balloon, how much? 1217.5 kg. So after doing this, you will get 3811.1 kg. This is important model for IIT students. Compulsory. This is very important. Very rare bits are given. This type of model you can find very rarely. This one you can do. Same model we did. Next. Next question. The average velocity or average speed. So here average velocity at T1. You can write average speed or average velocity at T1 Kelvin, T1 degrees Celsius, actually it is given Kelvin. Okay. And the most probable speed or velocity at T2 degrees Kelvin of carbon dioxide gas is given. Calculate the values of T1 and T2. So very easy, students. You already know average velocity. I have given one relation for you. Average velocity is equal to 0.9213 times RMS velocity. So from this 0.9213 into RMS velocity, what is the formula for RMS velocity? Square root of 3RT by M. So that is equal to, so here, come on quick, 0.9213 into square root of 3 into R value, how much, students? I am taking 8.314. So in centimeters now, into 10 power 7 ergs I will take R value, because in CGS system it is there. into T1 by 44 grams. Molecular mass is in grams na, gram per mole. So I am applying CGS system. Be careful here. Here you have to take R value as, because in terms of erg I am taking, right? So 0. If you solve this one, you do quick calculation. So average velocity. So what is the average velocity given? Students, read the question. 9 into 10 power 4 is equal to, and if you solve this, you multiply here the same thing. 3 into square root of 3 into 8.314 into 10 power 7 into square T1 by 44. So you solve this, from this you will get T1, lengthy calculation, NCERT numerical student, hot numerical, higher order thinking numerical. So if you solve this one, you will get T1 value 1682.5 Kelvin. So that is T1. Next, what is has given? Most is asking us to calculate. Next, what I will do is most probable velocity. Most probable velocity or speed is equal to, what is the formula, students? Square root of 2RT by capital M. So here most probable velocity, how much it is given? It is also given as same value. So that is equal to square root of 2 into 8.314 into 10 power 7. You have to take R value in terms of X. So into T2 divided by molar mass of carbon dioxide 44. So if you solve this one, you will get T2 value as 2143 Kelvin. This is also important model, but while during examination, easy going calculations they will give. Okay, students, next. Come on, quick. Calculate the root mean square speed, RMS, of ozone kept in a closed vessel at 20 degrees Celsius and pressure of 82 cm of Hg. So volume occupied by 1 mole of ozone at 20 degrees Celsius and 82 cm pressure can be calculated as. So what formula he has used here? This is STP condition. This is normal given condition. So he applied the formula P1 V1 by T1. STP condition means standard temperature and pressure. P2 V2 by T2. From this, by using this formula, he calculated this V2 value, right? After that, what he did, pressure is given in terms of, so you have to convert that pressure. Pressure actually, it is in centimeter of Hg. Pressure is converted to dyne centimeter, dynes per centimeter square. So what he did, 82 into, this is important, centimeter of Hg, here 13.6 into 981. 981, if you multiply, pressure value will be converted to dynes per centimeter square. So after that formula you apply, RMS velocity formula you apply. This is RMS, CRMS, okay, 3 PV by. So finally he substituted the total value and volume also 22,000 something he has taken by 48. Ozone molecular mass 48. Finally you will get in centimeter per second. So be careful, in all should be taken in one system only, either in SI system or in CGS system. Be careful. If it is in SI system, molecular mass must be expressed in terms of kg. So here atmosphere, like that, everything you have to convert. So total numerical is done in CGS system. That's why I got like this. Next. See here, a mixture of carbon monoxide and carbon dioxide is found to have, see students, all questions are hard questions, higher order thinking questions. So maybe somewhat tough, but we have to practice them. A mixture of carbon monoxide and carbon dioxide is found to have a density of 1.50 gram per liter at 20 degrees Celsius and 740 mm of pressure. Calculate the composition of the mixture. So how much percentage of carbon dioxide and carbon monoxide are present in the mixture? So calculation of average molecular mass of the mixture. So you know formula, Pm is equal to dRT. Already we have derived this formula. From that molar mass, what formula he applied? Pm is equal to dRT. From that molecular mass, so it is given, density is given, and R value you have to take in liter atmosphere Kelvin inverse, temperature, and you have to convert pressure. So total is taken in SI system. So here it is 740 by 760. Actually 740 mm of Hg. Pressure is equal to 740 mm of Hg and this should be converted into atmospheres, means you have to multiply with 760. So then it will be directly you can convert into ATM. So after getting that molecular mass, I got 37.06. So next, calculation of percentage composition. So percentage composition means, suppose let mole percentage of carbon monoxide in the mixture be X. Let X be the mole percentage of carbon monoxide in the mixture. So then what will be the mole percentage of carbon dioxide in the mixture? 100 minus X. So two gases are there, carbon monoxide and carbon dioxide. So percentage of carbon monoxide in the mixture is X. Percentage of carbon dioxide in the mixture is 100 minus X. So average molecular mass, starting basic concepts of chemistry, you got this formula. Average molecular mass is equal to X into 28. 28 from where you got? Molecular mass of this 28 we got molecular, it is the molecular weight of carbon monoxide. So here percentage composition of carbon monoxide into molecular weight of, so what formula you have to use? Average molecular mass is equal to percentage of carbon monoxide into its molecular weight divided by, again I will write, average molar mass is equal to percentage of carbon monoxide into molecular weight, it's plus percentage of carbon dioxide into its molecular weight divided by 100. So this formula they have used. So directly you substitute from the above data and finally you will get X value. After that, mole percentage of carbon monoxide is equal to 43.38, mole percentage of carbon dioxide is equal to 100 minus X, that is 100 minus 43.38. This is numerical based on mole concept only, but related to, they are interrelated. Okay students, so all these are different models. Next, next question. See here, calculate the average kinetic energy of 8 grams of molecules of methane. Calculate the average kinetic energy of 8 gram molecules of methane at 27 degrees Celsius in joule. Joule they are asking. So here N represents number of moles actually. So you know already formula kinetic energy for N moles of gas, that is 3/2 nRT from kinetic gas equation. So number of moles of methane is equal to mass of methane by gram molar mass. So here number of moles, mass how much? 8 grams. Gram molecular mass of methane is 16, CH4, that is 16. So you will get 0.5 mole. N value here you will get 0.5 mole, and directly you can substitute students. So kinetic energy is equal to 3/2 into 0.5 into R value how much? I am taking in SI system. It is given in brackets 8.314 in joule Kelvin inverse mole inverse. So solve this one, you will get 1870.65 joules. So that is the kinetic energy expression, total kinetic energy. But they are asking average kinetic energy. This is the kinetic energy expression. Average kinetic energy of 8 grams of methane they are asking. So here average kinetic energy is equal to, you have to take ratio between kinetic energy divided by per mole. How many moles? 0.5 mole into, you have to convert into, multiply with Avogadro number. So that is the average kinetic energy. Very important model students. You will get average kinetic energy in joules. If they ask only kinetic energy, that answer will be 1870. But average kinetic energy per mole, not per mole also, average kinetic energy of 8 gram molecules, in terms of molecules they are asking, not per mole. Per mole means simply you have to divide with 0.5 mole. But that moles must be converted into molecules. That's why you have to multiply 0.5 with Avogadro number. Then you will get average kinetic energy of 8 gram molecules, you will get it. Quick. For a gas containing 10 power 23 molecules, each having mass 10 power minus 22 grams in a volume of 1 dm cube, Calculate the total kinetic energy of molecules. If their root mean square speed is 10 power 5 centimeter per second, what will be its temperature? What will be its temperature? So, read the question properly. See here, total kinetic energy is equal to N into half m c square. So N here is 10 power 23 molecules into half into mass. How much given? Mass in terms of kg, you take mass 10 power minus 25 kg into C value. C value how much it is given? In terms of centimeters it is given. I am converting into meter. 10 power 3 meter per second. Okay, whole square. So if you multiply this, you will get total kinetic energy. You will get total kinetic energy, that is 0.5 into 10 power 4 joule you will get. In terms of joules, SI system I have taken. So total kinetic energy you already know. Total kinetic energy is equal to N into 3 by 2 kT. N into 3 by 2 kT. So here you equate these two equations. So 0.5 into 10 power 4 is equal to N into 3 by 2 kT. So here from this you are supposed to calculate temperature. So 0.5 into 10 power 4 is equal to N value. N value 10 power 23 into 3 by 2 into what is Boltzmann constant K value 1.38066 into 10 power minus 23 into T. Solve this one, you will get temperature, you will get in Kelvin directly. So big calculations you have to do. Next, average velocity of carbon dioxide. Average velocity of carbon dioxide at the temperature T1 Kelvin and maximum, that is most probable velocity of carbon dioxide at the temperature T2 is given. So calculate the values of T1, T2. Already we did this model. Same model we did, I think so. So you can convert this. Already we did this model, students. T1, T2 calculation. T1, T2. Already we did this model. Repeated. Next. You can use the formulas and do it, students. Same direct formula you can apply. Okay. Next. Calculate the temperature at which root mean square velocity, average velocity and most probable velocity of oxygen gas are all equal at 1500 meter per second. Okay. At what temperature all the three velocities are equal here he is asking. So here first root mean square velocity I am doing square root of 3r_T1 by capital M, that is root RMS velocity CRMS is equal to, so that is equal to 1.5 into 10 cube meter per second. Okay, so I'll give hints only, you have to solve it. So do it. From this you can get squaring on both sides. 3r_T1 by M is equal to 1.5 into 1.5 into 10 power 6. Okay, double squaring on both sides. So R value how much you will take? SI system 8.314 into T1 by molecular mass. Molecular mass how much? In kg you have to take. Oxygen, molecular mass of oxygen how much? 32 into 10 power minus 3 kg. So is equal to 1.5 into 1.5 into 10 power 6. So if you solve this one, you will get temperature, students. T1 value, you will get 2886 Kelvin. If you want, once you check the answer also. So after that, average velocity, average speed or average velocity is equal to, square root of 8r T2 by pi m. So that is equal to square root of 8 into, so average velocity how much it is here? 8 into 8.314 into T2 by pi value 3.14 into molecular mass 32 into 10 power minus 3 kg. So average velocity how much given? It is given as same equal 1.5 into 10 cube is equal to, so squaring you do directly, okay, otherwise take this 8 into 8.314 into T2 by 3.14 into 32 into 10 power minus 3. So squaring on both sides, and finally you solve this, you should get temperature T2 value 3399 Kelvin. Next, after that, most probable velocity. Most probable velocity is equal to formula what? Square root of 2r T3 by m. So most probable velocity you have to take it as 1.5 into 10 power minus 3 is equal to, come on quick, square root of 2 into 8.314 into T3 by 32 into 10 power minus 3 molecular mass of oxygen. So this squaring on both sides, so 1.5 into, here I am taking directly, that is equal to 2 into 8.314 into T3 by 32 into 10 power minus 3. Solve this one, students. You will get T3 value as 4330 Kelvin. Next, calculate the temperature at which the average velocity of oxygen is equals that of hydrogen at 20 Kelvin. Calculate the temperature at which the average velocity of oxygen equals to that of hydrogen. So oxygen versus hydrogen gases. So average velocity. So I can take C bar. This is average velocity is equal to square root of 3r T by m. From this you can write average velocity is proportional to square root of T by m. Okay. So two different average velocities given at two different temperatures. Calculate the temperature at which average velocity of oxygen equals to hydrogen at 20 Kelvin temperature. So here average velocity of oxygen is proportional to temperature of oxygen by molar mass of oxygen. Okay. At the same time, average velocity of other gas, what? Hydrogen, is proportional to square root of temperature of hydrogen divided by molecular mass of hydrogen. So take the ratio between these two. So from this, C bar average of oxygen by C bar average of hydrogen is equal to square root of T oxygen by m molecular mass of oxygen into molecular mass of hydrogen divided by temperature of hydrogen. So what is the average velocity here given? How much? Calculate the temperature at which average velocity of oxygen is equals to that of hydrogen. So it is given that both velocities are equal. So one I will take. Both gets cancelled because it is given that C bar average of oxygen is equal to C bar average of hydrogen, right? It is given like this. So I am writing one. Both gets cancelled. So is equal to square root of oxygen. How much given? We don't know. temperature of oxygen by molecular mass 32, here 2, by temperature of hydrogen, how much given? 20 Kelvin. So do it, you will solve it and you will get temperature of oxygen is equal to 32 into 20 by 2. So you will get 320 Kelvin, right? Very easy sum. Next, which of the following gases will have highest RMS velocity? Very important for objective. Which of the following gases will have the highest RMS velocity at 25 degrees Celsius? At 25 degrees Celsius they are asking. Oxygen, carbon dioxide. So here RMS velocity, CRMS, is equal to square root of 3RT by capital M. So from this we can write CRMS is inversely proportional to square root of M, molecular mass. So from this, so what is the molecular mass of oxygen? Here 32, here 44, here 64, here 28. The one which has got low molecular mass will have greater RMS velocity because CRMS is inversely proportional to square root of molecular weight. So which gas possesses highest RMS velocity? The gas which possesses lower molecular weight possesses highest RMS velocity. Very easy bit but important for objective. These type of questions only they will ask in objective. Next, which of the following expressions correctly represents the relationship between average molar kinetic energy of carbon monoxide and molecules and nitrogen molecules at the same temperature? So you already know average kinetic energy per mole, that is 3 by 2 RT. For 1 mole I have taken. So it doesn't depend upon the nature of the gas. So average kinetic energy doesn't depend on the nature of the gas. It doesn't depend upon nature of the gas. Same temperature, at the same time you already know average kinetic energy is directly proportional to absolute temperature. So same temperature they are asking. So the answer will be option A, because average kinetic energy of any gas doesn't depend on nature of the gas, it depends only on absolute temperature. Here it is given as same temperature, that's why both will have equal average kinetic energies. Very important model for IIT and NEET. Most of the students will get confused here. These type of bits only they will ask. The ratio of root mean square velocity of hydrogen at 50 Kelvin to that of oxygen at 800 Kelvin is. So root mean square velocity CRMS is equal to, according to our formula, CRMS. So CRMS is proportional to square root of T by M. So CRMS of hydrogen at 50 Kelvin. So take this formula, that's all. Hydrogen and oxygen, same formula. So CRMS, how can you write? CRMS of hydrogen is equal to square root of temperature of hydrogen by molar mass of hydrogen. Okay. At the same time, CRMS of other gas, oxygen, is equal to square root of temperature of oxygen by molar mass of oxygen. So you take the ratio, that only he did. CRMS of hydrogen divided by CRMS of oxygen is equal to, so here you can write temperature TH2 by molecular mass of hydrogen 2 into molecular mass of oxygen, temperature of oxygen. So solve that one, you will get the answer. Okay students, very easy model. Next, read the question. So big one. Two bulbs A and B of equal capacity are filled with helium and sulfur dioxide respectively. Two gases. Two bulbs are filled with two gases. Bulb A is filled with helium, bulb B is filled with sulfur dioxide at the same temperature. If the pressures in the two bulbs are same, first question, if the pressures in the two bulbs are same, what will be the ratio of velocities of molecules of the two gases? First question I am doing. If the pressures in the two bulbs are same, what will be the ratio of velocities of molecules of the two gases? So how to sort it out? let CRMS velocities of helium and sulfur dioxide be U1 and U2 respectively. I am taking U1 and U2. Okay. Now U1 is equal to square root of 3RT by molecular mass of helium. U2 is equal to square root of 3RT by molar mass of sulfur dioxide. So from this you can take the ratio between U1 by U2 is equal to, you will get molecular mass of sulfur dioxide by molecular mass of helium. So that is equal to square root of 64 by 4. So that is equal to 4. So pressures are same. What will the ratio of their velocities? It is given, ratio is 4:1. Next, second one, how you will do? Read the second question. At what temperature will the velocity of sulfur dioxide molecules become half of the velocity of helium molecules at 27 degrees Celsius? What temperature will the velocity of sulfur dioxide? See here also same thing, very easy bit. Second condition I am doing, let the velocity of helium be U1, and it is given that velocity of sulfur dioxide is equal to U1 by 2. So velocity of sulfur dioxide is given as U1 by 2, that is U2 is equal to U1 by 2. Okay. Now, so like this you write U1 is equal to square root of 3RT1 by molar mass of helium. U2 is equal to square root of 3RT2 by molecular mass of sulfur dioxide. So from this you take, this is U1 and U2. Okay, this is U1 and U2. So from this U1 by U2 is equal to square root of 3RT1 by, so helium is 4 by square root of 3RT2 by 64. So take the ratio U1. So here U2, in place of U2 you can write U1 by 2 is equal to, what you will get? Do that calculation. In place of U2 I am writing U1 by 2. So square root of 3RT1 by 4 into 64 by 3RT2. Cancel the common terms. So here U1 by 2. So you will get 2. So solve this one, students. If you solve this one, you will get, what is T1 value given here? T1 value, how much it is given? 27 degrees. Here it is given T1 as 27 degrees Celsius, that is equal to 27 plus 273. So that is equal to 300 Kelvin. T1 value, substitute in this. So here U1 by 2. So 2 is equal to square root of 3R cancel. So 300 into 64 by 4. 4 ones, 4 16s. Where is T2 here? Right here into T2. So from this you calculate T2 value, you will get the answer. Okay, students. Next, third question you see in the same. How will the velocities be affected if the volume of B becomes 4 times that of A? How will the velocities be affected if the volume of B becomes 4 times that of A? So C option I am doing. Velocity given by the relation. So you know RMS velocity. CRMS is equal to square root of 3 PV by M. So when volume increases by 4 times, pressure becomes 1 by 4. So when, see here, when volume increases by 4 times, pressure becomes 1 by 4. Pressure becomes 1 by 4, and PV value remains constant. PV remains constant. So there will be no change in the velocities. So there will be no change in the velocities. No change in the velocities. Okay. Next, fourth question, what he has given. How will the velocities be affected if the half of the molecules of sulfur dioxide are removed from B? So for that, what explanation we can get it? Since velocities don't depend upon number of molecules, since velocities don't depend on the number of molecules, there will be no change in the velocities. There will be no change in the velocities. So think properly. Next, calculate the root mean square velocity of nitrogen at 27 degrees Celsius and 70 centimeter pressure. Density is given, it has 13.6 gram per cm cube. So see, one is STP condition you take, students. One is STP condition and other one is normal condition you take. First of all, STP condition means here I will take P1 as 76 centimeters of mercury and here P1 as volume 0.0224 cm cube I am taking. See the units properly. At STP, temperature I will take it as 273 Kelvin, and under normal condition P2 I will take it as 70 centimeter of Hg, and what is the volume P2 I am supposed to calculate it. Temperature T2 300 Kelvin. 27 degrees means 300 Kelvin. So you solve by using P1 V1 by T1 is equal to P2 V2 by T2. So from this, if you solve, you are going to get V2 value as 0.026725 cm cube. So first you calculate V2 value. After that, pressure you have to convert in SI system. Pressure it is given as 70 centimeter of Hg. So that will be converted into different system. 70 by 76 into 1.01325 into 10 power 5. If you multiply, you will get answer in Newton per meter square. I am converting pressure. So directly, if I convert that, I will get 9.332 into 10 power 4 Newton per meter square pressure value. In SI system, I converted that one. So CRMS is equal to square root of 3 PV by M. So that is equal to square root of 3 into P value. I can take 9.332 into 10 power 4 into here V value, volume, how much we got? Centimeter cube. 0.026 I have to take into 10 cube. In dm cube I want to convert. Decimeter cube. and even mass you have to take it as 28 into 10 power minus 3 kg per mole. So solve this one, students, you will get the answer. RMS velocity you will get in meter per second. So lengthy question. Do it. Read that question. Read that question, students. Two flasks A and B have equal volumes. A is maintained at 300 Kelvin, B is at 600 Kelvin. While A contains hydrogen, B has an equal mass of methane gas. Assuming ideal behavior of both the gases, which of the following is true about the velocities of molecules? Which of the following is true about the velocities of the molecules? Do it. See, actually, quick, read the question properly. You already know kinetic energy per mole is equal to 3 by 2 RT per mole. So from this, kinetic energy is directly proportional to temperature. So from this you can write kinetic energy A by kinetic energy B is equal to TA by TB, right? So it is given as two flasks A and B have equal volume. A is maintained at 300 Kelvin, B is at 600 Kelvin. So 300 by 600. So then it becomes 1 by 2. So B option is correct. Molecules in flask A are moving 2 times faster than molecules in. So from this you can write two flasks. So kinetic energy B is equal to 2 times kinetic energy A. So option B is the correct option. Next. Two flasks A and B are of equal volume or at temperatures 100 and 200 Kelvin containing hydrogen and methane gas respectively. Which of the following is true about kinetic energy per mole? So same model you can do, students. Kinetic energy per mole. So same method. Same method you can apply. Do it in the same manner. Next, the kinetic energy of molecules at constant temperature in gaseous state is. Kinetic energy of molecules at constant temperature in gaseous state is. So according to that, kinetic energy of molecules at constant temperature in gaseous state is equal to those in the liquid state. because kinetic energy is equal to 3 by 2 RT in gaseous and liquid phase. Both equation holds good. So you should get equal to those in the liquid state, because kinetic energy is equal to 3 by 2 RT. Equation holds good in both gaseous and liquid phase. Two flasks A and B of equal volume containing equal masses, temperatures given. Which of the following is true about kinetic energy? Same method. So total kinetic energy is equal to, what formula you will use for this? Total kinetic energy is equal to kinetic energy per mole into number of molecules. So total kinetic energy is equal to, here 3 by 2 for first gas, that is kTA. Actually 3 by 2 kT, K represents Boltzmann constant, and number of molecules you can take it as Na. So that is total kinetic energy A value. Okay, this is total kinetic energy A, first equation. Next, total kinetic energy B is equal to 3 by 2 KTB NB, second equation. If you take the ratio, what you will get? Total kinetic energy A by total kinetic energy B is equal to TA NA by TB NB. So here TA how much given? 100 by 200. Here Na, what is this gas A? Hydrogen. Na by Nb. So here number of moles of A is equal to mass by gram molar mass of A. Number of moles of B is equal to mass by gram molar mass of B. Okay. So in place of Na, what is that gas? Equal masses it is given. So I am taking, so here WA by MA by WB by MB. Okay. So it is given equal masses, equal volumes, equal masses. So you can take WA is equal to WB, and MA is equal to how much? Hydrogen gas 2 grams. MB, what is that gas name? Methane 16 grams. Substitute. So finally kinetic energy A by kinetic energy B is equal to 100 by 200 into, so 1 by, so both are same na, that's why I am taking 1, that is equal to 1. So 1 by MA 2 into 16 by 1. So if you solve, you will get half into 8, that is equal to 4. So from this you can write kinetic energy A is equal to 4 times kinetic energy B. Okay students, thank you very much for listening. Thank you.